All right. Welcome to your personalized deep dive.
Oh, cool.
Yeah. So today we're going to be looking at your handwritten notes and diagrams all about Kubernetes.
Awesome.
It's kind of like we're peeking right over your shoulder as you were learning, you know? So
Right.
your goal was to really get a grip on Kubernetes.
hmm
And I think we can uncover some surprising connections along the way, for sure.
What I thought was really interesting was how you jumped right into like the practical challenges of container management.
Oh, yeah.
You were clearly thinking about real-world applications from the start,
Yeah, for sure.
which I love.
Yeah. So, okay. So the notes start off with a pretty straightforward definition of Kubernetes, right?
hmm
Container orchestration engine.
Yeah,
But honestly, what does that even mean for someone who's just starting out?
right.
Right.
Well, think about it like this. You're building a complex application,
Okay.
and it's made up of different pieces, like a puzzle. Each piece is a container, a little package containing all the code and dependencies it needs to run.
Okay. I get the container part.
Yeah.
But why can't I just run those pieces myself? What's this whole orchestration business about?
Imagine trying to solve a 1,000-piece puzzle all at once without any organization. That's what managing lots of containers can feel like without Kubernetes.
Yeah.
It handles all those tricky parts like deploying containers, scaling them up or down, making sure they're healthy, even restarting them if they crash.
So it's like having a super organized project manager
Right.
for my containers.
Exactly.
Keeps everything running smoothly, even when things get chaotic.
Yeah. And you've even sketched out some of the key players
Yeah.
involved in this whole orchestration thing,
Yeah.
like the node and the cluster.
Mm-hmm.
You've got a great visual representation of how they all work together.
Yeah, I see in my notes, I defined a node as the individual machine where the work happens.
Okay.
Kind of like a single computer in a network, right?
Precisely. And a cluster is just a group of these nodes all working in harmony.
All right.
Your notes actually compare it to a restaurant kitchen, with each node being a cooking station.
Ah, I remember that.
You got it.
So it's like all these cooks, working together to prepare a meal.
Uh-huh.
But in this case, the meal is my application.
That's a delicious analogy.
Okay.
And just like a well-run kitchen has a head chef, a Kubernetes cluster has a master node.
The master node, right, that runs Kubernetes itself.
Oh.
So it's like calling the shots, making sure all the other nodes are doing their jobs.
Exactly.
Okay.
Then you've got worker nodes.
Worker node.
Those are where the containers actually run.
Um.
Those are like the individual cooking stations where the magic happens.
Right.
So we've got our head chef, our cooking stations.
Mm-hmm.
And then my notes go a bit deeper talking about Kubelo.
Kubelet.
Yeah, what's its role in all this?
Yeah, what is Kubelet?
Well, Kubelet is like the sous chef on each worker node,
Okay.
making sure the containers are prepped and cooking as expected.
Sorry.
Like the hands-on manager keeping things in order at that individual station.
Okay, so we've got our head chef, our sous chefs,
Mm-hmm.
and our cooking stations.
Yep.
What about communication?
Ooh, good question.
How do all these components talk to each other?
That's where the API server comes in,
APIs.
like the central communication hub of the kitchen,
Okay.
taking orders, delegating tasks.
So like if one of the sous chefs needs more, I don't know,
Exactly.
potatoes or something?
They go to the API server and say,
Yeah.
hey, we're running low on potatoes over here.
I see. I even drew a little diagram of that in my notes with arrows pointing to the API server from all the other components.
You've got a knack for visualization, I see.
Trying to.
Now, what happens if a container crashes or a node goes down?
Oh, that's a good question.
That's where the controller steps in.
Controller? All right, so the controller is like the quality control manager,
Yeah.
making sure everything's running smoothly and fixing any issues that come up.
Exactly. It monitors the state of the cluster
Okay.
and takes action if something goes wrong,
Like what kind of action?
like restarting a failed container
Okay.
or rescheduling it to a different node.
Oh, interesting.
Yeah.
My notes mention the scheduler plays a crucial role in this rescheduling process.
Yes.
How does it decide where to place containers?
Well, think of the scheduler as the host assigning tables in the restaurant.
Okay.
It considers things like resource availability,
Mm-hmm.
node capacity,
Okay.
and any constraints you've defined to make sure that those containers land on the most suitable nodes.
So it's optimizing the use of resources and making sure no single node gets overloaded.
Exactly.
Cool.
And finally, we have et cetera,
Etc. Oh, I remember this.
which stores all the important cluster data.
Yeah, in my notes, I compared etc. to a shared recipe book,
Oh, I like that.
accessible to everyone in the kitchen.
Perfect analogy.
All right.
It holds all the configuration information,
Yeah.
the state of the cluster, the desired state of your applications, everything's in there.
Now, my notes also mentioned Docker.
Ah, yes.
It seems to be connected to Kubernetes somehow.
Yeah,
I'm a little fuzzy on that part.
that's a great question, and it's a common point of confusion for beginners.
Oh, okay.
Docker provides the containerization technology
Okay.
that Kubernetes leverages.
Mm-hmm.
It's like the set of tools and standards used to create and package those individual containers.
Okay.
So Docker is responsible for building the cooking stations, if you will,
Yeah.
and Kubernetes is responsible for managing the entire kitchen.
Okay. Now that makes a lot more sense.
Awesome.
I feel like we've got a pretty good handle on the overall architecture.
Yeah.
But how do we actually start working with Kubernetes?
That's the big question, right?
Yeah, where do the containers actually live?
That brings us to one of the most fundamental concepts in Kubernetes,
Okay.
pods.
CODs.
Yeah, your notes actually call them the smallest object of Kubernetes.
Right. I remember struggling with that concept at first.
Yeah.
What exactly is a pod and why is it so important?
A pod is the smallest deployable unit in Kubernetes.
Okay.
Think of it as a single unit of deployment, typically containing one container.
Right. So one container, one pod.
Usual, yeah.
But I also see in my notes that different containers from the same application can be in a single pod.
Right.
Why would you do that?
Imagine a dish that requires a separate sauce or garnish.
Okay.
You might have two containers.
Yeah.
One for the main dish,
Okay.
one for the sauce.
Gotcha.
But they're logically part of the same unit.
They go together.
Exactly.
But then why not just put all the containers for my application in one giant pod?
That's a great question.
Yeah.
And it highlights a key principle of Kubernetes,
Okay.
separation of concerns.
Separation of concern.
While containers within a pod can share resources and communicate closely,
Mm-hmm.
containers from different applications
Okay.
should be in separate pods.
So it's all about keeping things organized and modular.
Exactly.
All right.
Each pod represents a distinct piece of the overall application puzzle.
Gotcha. Okay, so how do we actually create a pod in Kubernetes?
Yes, the nitty-gritty.
My notes mentioned the kubectl command line tool.
Right.
I even have an example written down.
Okay, me.
Kubectl run ingdexis image ginks.
All right, so you're instructing Kubernetes to create a pod named tunings
Mm-hmm.
using the nginx image,
Okay.
which is a simple web server.
All right.
It's like a hello world of web servers,
Gotcha.
just for testing purposes.
Okay, so kubectl is our primary way of interacting with the Kubernetes cluster.
Exactly. It's like giving instructions to the head chef.
Okay, but where does this nginx image come from?
Excellent question. That image is pulled from a public repository like Docker Hub,
Docker Hub.
which is a VAB library of pre-built container images readily available for use.
So it's like grabbing a pre-made spice blend instead of measuring out every spice individually.
I love that analogy. It's perfect.
All right.
Yeah, it saves a lot of time and effort.
Definitely. But I also see some notes about YAML files.
Ah, YAML files.
How do those fit into the picture?
YAML files provide a more structured and declarative way to define Kubernetes objects, including pods.
Okay.
You've even highlighted some key fields in your notes: API version, kind, metadata, and spec.
Right. I remember being a bit overwhelmed by all those fields at first.
Yeah, it can be a lot.
What are the most important ones to understand?
Okay, well, API version specifies the version of the Kubernetes API you're using.
So kind of like choosing the right recipe book for your dish.
Exactly.
Oh, okay.
And kind simply states what type of object you're creating.
Like a pod.
In this case, a pod. Yeah,
That seems pretty straightforward.
exactly.
Okay.
Metadata provides information about the object,
All right.
like its name,
Okay.
and any labels you want to apply for organization and identification.
So kind of like adding a name tag and some descriptive keywords to our pod
Precisely.
so we can easily find it later.
Yep, but the spec section is where the real magic happens.
Spec. Okay.
This is where you define the details of the container itself, including the image to use and any configuration settings.
So the spec is like the actual recipe for our dish,
Yes,
while the other fields provide context and organization.
I couldn't have put it better myself.
Okay.
You're really starting to grasp the core concepts here.
Well, hopefully, but creating a pod is just the first step, right?
Right.
What about managing them once they're up and running?
That's a great point. Your notes mentioned several kubectl commands for managing pods.
Yeah,
Do you want to walk through some of the most common ones?
sure.
Okay, we've already seen kubectl run to create a pod directly,
Mm-hmm.
but you can also create a pod from a YAML file.
Okay.
Using kubectl create-f pod definition.yaml.
All right.
And to see a list of all your pods, you'd use kubectl to get pods out.
Okay, and to get more detailed information about a specific pod, like its status, resource usage, and logs, you can use kubectl describe pod, my pod.
Exactly.
Right.
And if you need to make changes to an existing pod,
Yeah.
you can use kubectl edit log pod name to modify its YAML definition.
Okay, so we can manage pods both directly using imperative commands like kubectl run, and by defining them in YAML files and applying those files to the cluster.
You got it.
Okay.
That's one of the strengths of Kubernetes.
All right.
It offers flexibility in how you interact with the system.
But my notes seem to emphasize using YAML files,
Yes.
especially for production environments.
Right.
Any particular reason for that?
YAML files provide a number of advantages.
Like what?
Well, they allow for version control,
Okay.
which is crucial for tracking changes and rolling back if needed.
Yeah, that's important.
They promote reusability, so you can easily deploy the same pod configuration across different environments.
Makes sense.
And they provide a clear and auditable record of your pod configurations, which is invaluable for troubleshooting and collaboration.
Okay, cool. So we've created our pods and we know how to manage them.
Right.
But how do we ensure that they're running as intended?
That's where controllers come into play.
Controllers,
Nope,
my notes have a whole section on controllers. But I'll admit, I'm still a bit fuzzy on what they actually do.
Sure.
It seems like they're crucial for keeping things running smoothly, though.
You're absolutely right. Controllers are the unsung heroes of Kubernetes,
Okay.
working tirelessly behind the scenes to maintain the desired state of your applications.
So they're like the kitchen managers,
They get it.
ensuring everything runs according to plan.
Yep.
Okay, that makes sense. But my notes specifically mention 2DO types of controllers,
Okay.
replication controllers, and replica sets.
Yes. What's the difference?
Yeah, and which one should I be using?
Think of replication controllers as the seasoned veterans.
Okay.
They've been around for a while, and they do a solid job of maintaining a specified number of pods on nodes.
Okay.
If a pod fails,
Yeah.
the replication controller spins up a new one to replace it.
So it's like having a backup chef ready to step in if someone gets sick or injured.
A fantastic analogy.
Keeps the kitchen running smoothly even when things go wrong.
Exactly. This is what we call self-healing.
Self-heal.
Kubernetes automatically recovers from failures,
Oh, wow.
ensuring that your application remains available.
That's impressive, but my notes also mention replica sets.
Right.
Are they just a newer version of replication controllers?
Replica sets build upon the foundation of replication controllers,
Okay.
offering more sophisticated features and capabilities.
Like what kind of features?
Think of them as the new generation of kitchen managers,
Right.
bringing fresh ideas and more efficient tools to the table.
So they offer more control and flexibility in how we manage our pods.
Exactly.
Okay, and you're right, they are generally the recommended approach these days.
Yeah, for sure.
Okay, so replica sets are the way to go, but how do we actually define and create them? I see some YAML examples in my notes,
Right.
but they look a bit daunting.
Don't worry, they're not as complicated as they might seem at first glance.
Okay.
The YAML definition for a replica set
Mm-hmm.
is actually quite similar to that of a pod.
Similar to a pod. Okay.
You'll have the same basic structure with fields like app version, kind, and metadata.
Okay, so far so good.
What about the spec section?
Spec, are there any specific fields that I should be paying attention to there?
Absolutely. One of the most important fields in a replica set spec is replicas,
Replicas.
which determines the desired number of pods you want running at any given time.
Okay.
You've even highlighted this field in your notes, indicating you understand its significance.
Right. It's basically how many cooking stations we want to have active for a particular dish.
Exactly.
Okay.
And to create a replica set from a YAML file,
Yeah.
you'd use the familiar kubect create repis rss-definition.yaml command.
Okay, that makes sense. But what if we need to change the number of replicas later?
Yeah,
Do we have to create a whole new replica set?
not at all.
Okay.
Kubernetes offers several ways to update your replica sets.
Okay.
You can use kubectl replace -f replica set-dfn.yam to provide an updated YAML file with the new desired number of replicas.
So we can easily scale our application up or down by simply modifying that replica's value.
Precisely.
Okay.
And Kubernetes handles the rest,
Wow.
gracefully adding or removing pods as needed to match your desired state.
That's incredibly powerful.
It is.
But my notes also mentioned deployments
Deployments, yeah.
as an even higher level of abstraction.
That's right.
What role do they play in managing pods?
Deployments are like the executive chefs,
Okay.
overseeing the entire process of preparing and serving a dish.
Right.
They manage replica sets,
Mm-hmm.
and they provide a streamlined way to handle updates and rollbacks.
So they automate the creation and management of replica sets, making it even easier to manage our applications.
Exactly.
Okay.
And just like replica feds,
Yeah.
deployments are defined using YAML files.
Right.
The structure is very similar,
Mm-hmm.
but the kind field will be deployment.
Gotcha. So we've got pods,
Yes.
replication controllers, replica sets,
Right.
and deployments.
It's a lot to keep track of.
It is a lot to keep track of.
But you're doing great.
I'm trying.
It's like learning the different roles and responsibilities in a busy kitchen.
Yeah.
And believe me, we've only just scratched the surface.
That's both exciting and a little intimidating.
I know, right?
But I'm eager to learn more.
Awesome.
Shall we take a quick pause here to let everything sink in?
That's a great idea. We'll be right back to continue our deep dive into your Kubernetes notes.
Welcome back to our Kubernetes deep dive.
We left off talking about deployments, those executive chefs of Kubernetes.
Yeah.
You even circled the phrase rolling update in your notes.
Rolling updates.
What caught your eye there?
Well, I mean, it seems pretty important how Kubernetes handles updates without interrupting service.
Right.
Imagine you're running a website and you need to update the code.
Mm-hmm.
With a rolling update, Kubernetes gracefully replaces old pods with new ones, one by one,
Yeah.
ensuring the site stays up and running throughout the process.
It's pretty amazing,
Yeah.
isn't it?
Yeah, it's like swapping out engines in a plane mid-flight without anyone noticing.
Exactly.
But speaking of updates,
Yeah.
my notes also have a section on scaling and managing applications.
Right.
What are some of the key commands I jotted down?
You've clearly been paying attention to how Kubernetes handles changes in demand.
Oh, hey.
You even highlighted the command kubectl scale replica, 6-f replicaset.yaml.
Okay.
This allows you to instantly adjust the number of pods in a replica set.
Okay.
In this case, scaling up to 6 replicas to handle increased traffic or workload.
Right. And if things calm down, I can scale back down just as easily by changing that replica count.
Exactly.
No need to create a whole new replica set.
Kubernetes makes it incredibly simple to adapt to fluctuating demands.
Yeah, okay.
And if a replica set is no longer needed, you've also noted the command kubectl delete replica set myappers to remove it completely.
Yeah, just get rid of it.
Out with the old.
It's interesting how all these commands are built around managing replica sets. It really reinforces how central they are to the Kubernetes workflow.
They really are. They provide a consistent and reliable way to manage the desired state of your application, whether you're scaling up, down, or even deleting it entirely.
Yeah. Now, my notes get a bit more abstract with the concept of namespaces.
Namespaces.
I remember scribbling down that they logically divide a Kubernetes cluster.
Okay.
Can you unpack that for me? Why would I even want to divide things up?
Imagine a large tech company with multiple teams all working on different projects. Each team needs its own isolated space within the Kubernetes cluster
Right.
to prevent conflicts and ensure security.
So it's kind of like giving each team their own mini Kubernetes cluster within the larger one.
That's a good way to think about it.
Okay.
Namespaces provide a way to logically separate resources, ensuring that teams can work independently without stepping on each other's toes.
I even drew a little diagram in my notes showing how resources within a namespace are only accessible within that namespace.
I love it when you visualize things.
So it's like having separate rooms in a house, each with its own set of furniture and appliances.
A perfect analogy.
All right, cool.
And your notes also show how to create a namespace using kubectl.
Yeah.
You can either use kubectl create namespace dev,
Okay.
or create it from a YAML file using kubectl create dav namespace -dev.yaml.
Right, so we've got options.
You clearly appreciate the flexibility Kubernetes offers.
Yeah, I'm all about flexibility, especially when you're dealing with complex systems.
For sure.
But what about managing resources within those namespaces?
Good question.
How do I prevent one team from hogging all the resources and leaving others with nothing?
That's a crucial consideration, and it's clear you've thought about it too.
Yeah.
Your notes highlight the concept of resource quotas,
Okay.
which allow you to limit the amount of CPU and memory a namespace can consume.
So it's like setting a budget for each team
Exactly.
to ensure that resources are shared fairly.
Yeah.
I even wrote down avoid resource starvation in big letters.
You're clearly taking this seriously.
Yeah.
The notes even provide an example of a resource quota defined in YAML, highlighting fields like request.cpu and limits.memory.
Yeah.
To enforce these quotas, you'd use kubectl create-f quota.yaml.
Awesome.
You were clearly taking good notes.
I'm trying to soak up as much as I can.
Great.
Now I see a section in my notes comparing two approaches to working with Kubernetes.
Okay.
Imperative and declarative.
Ah, yes, the classic debate.
Can you refresh my memory on what those mean?
Of course, imperative commands are like giving direct orders to Kubernetes,
Okay.
telling it exactly what to do, like kubectl run or kubectl scale.
Right.
It's like telling the chef, make me a salad and make it snappy.
Yeah.
Whereas declarative approaches involve defining the desired state in YAML files and letting Kubernetes figure out how to achieve it.
Okay.
It's like handing the chef a recipe and saying, here's what I want, make it happen.
All right.
And you seem to have grasped the key benefit of the declarative approach.
Oh, yeah.
You've circled the phrase version control in your notes.
Version control.
By defining your configuration in YAML files, you can track changes over time, revert to previous versions,
Right.
and even collaborate with others using familiar source control tools.
It's funny. I remember initially being drawn to imperative commands because they seemed simpler and more direct.
Yeah, it's a common first reaction.
But now I see the power and flexibility of defining things declaratively.
It might seem a bit more abstract at first,
Yeah.
but it offers significant advantages in terms of reproducibility, maintainability, and collaboration.
Now, there's a section in my notes that I find a bit confusing.
Okay, what's that?
Commands and arguments in Docker versus Kubernetes.
Yes, another subtle but important distinction.
Why is there a distinction? Aren't they essentially the same thing?
Well, both Docker and Kubernetes use concepts like CMD and entry point to define how containers are executed.
Okay.
Their behavior can differ.
I see. I even drew some arrows in my notes trying to map how arguments flow between Docker and Kubernetes.
Clearly, this was a point of struggle for you.
Yeah, it was.
It's a common area of confusion.
Okay, good.
In Docker, CMD specifies the default command to run when the container starts.
Okay.
You can override this command by providing different arguments when you run the container.
Right.
Entry point, on the other hand, defines a fixed entry point,
Okay.
and any arguments you provide are appended to the entry point command.
So in Docker, CMD is like a suggestion, and entry point is like a rule.
I like that. It's a good way to think about it.
All right.
Now, in Kubernetes, things work a bit differently.
How so?
You define the arguments to pass to the container in the args field of your pod definition.
Okay.
These arguments are then appended to the CMD defined in the container image.
Oh, I see.
So it's important to understand how these commands and arguments interact between Docker and Kubernetes to avoid unexpected behavior.
Makes sense.
Your diligence in noting these differences will definitely pay off as you work with more complex applications.
Speaking of complexity, my notes delve into environment variables and config maps. I remember feeling like these were crucial for configuring applications.
They are.
But the details are a bit blurry now. Can you shed some light on them?
Of course, environment variables are like settings dials on your kitchen appliances. They provide a way to configure applications without modifying their code.
All right.
For example, you might use an environment variable to specify the database connection string.
Okay.
Or the port number the application should listen on.
Okay.
And config maps are like those handy spice racks that keep everything organized and accessible.
Right.
They allow you to centrally manage configuration data and easily inject it into your pods.
Okay.
This keeps your configuration separate from your code, making it easier to manage and update.
I even have some examples in my notes showing different ways to inject configuration using environment variables and config maps. It seems like Kubernetes offers a lot of flexibility in this area.
Flexibility is one of its strengths.
But what about sensitive information, like passwords or API keys?
Yes, the secret ingredient.
Yeah. We wouldn't want to expose those in plain text, right?
You're right to be cautious.
Yeah. I have a whole section in my notes dedicated to secrets.
Right.
But I'm a bit apprehensive about how secure they actually are.
It's understandable.
You know, I underlined base 64 encoded with a big question mark.
It seems you're rightly concerned about security.
I try to be.
Secrets in Kubernetes provide a way to store sensitive information securely.
Okay.
They are base 64 encoded, which obscures the data but doesn't actually encrypt it.
So it's like hiding the key under the welcome mat. It's better than nothing.
Right.
But not exactly Fort Knox.
A fair assessment.
Okay.
While base 64 encoding offers a basic level of obfuscation, it's essential to understand that secrets are not a silver bullet for security.
Right.
You need to carefully consider the sensitivity of the information you're storing.
Yeah.
And implement additional security measures when necessary.
That's good advice. It's better to err on the side of caution when it comes to sensitive data. Now, shifting gears a bit, my notes also cover security contexts.
Security contexts.
I remember this being a dense topic.
Yeah, it can be a bit overwhelming.
Can you give me a high-level overview of why they're important?
Security contexts are like setting the security protocols for your kitchen.
Okay.
They allow you to fine-tune the permissions and capabilities of your containers, ensuring they only have access to the resources they need.
So it's like making sure the pastry chef can't accidentally turn on the deep fryer.
Exactly.
Okay.
You can specify things like running containers as non-root users,
Right.
limiting their Linux capabilities and restricting their access to specific parts of the file system.
Yeah.
You even highlighted the fields run as user and capabilities in your pod definition examples.
Right. Those fields allow for some granular control over what the container can and can't do.
They do.
It seems like security contexts add an extra layer of protection to our cluster.
Absolutely. They're a crucial part of building a secure and robust Kubernetes environment.
Now let's talk about service accounts.
Service accounts. Ah, yes. Remember those staff badges we talked about earlier?
Right. They're like digital identities for applications running within Kubernetes, granting them specific permissions to access resources.
You've even noted how to create service accounts and retrieve the associated tokens using Kubernetes.
Yeah.
These tokens are used for authentication, allowing applications to prove their identity when requesting access to resources.
I also see a note about automatic token mounting.
Yes.
What's that about?
When a pod is created,
Yeah.
Kubernetes automatically mounts the default service account token into a specific location within the pod's file system.
Oh, I see.
This makes it easy for applications running within the pod to access the token and authenticate themselves.
That's convenient.
It simplifies the authentication process for applications,
Mm-hmm.
but I imagine there are also security considerations to keep in mind.
Yeah, for sure.
While automatic token mounting is convenient,
Yeah.
it's crucial to carefully manage service account permissions and limit their access to only the resources they absolutely need.
It seems like security is a recurring theme in Kubernetes.
It's woven into the fabric of the platform.
It's not just about deploying and scaling applications.
Right.
It's also about building a secure foundation for everything to run on.
You've hit the nail on the head.
Wow, we've covered a lot of ground in this session.
We have.
From namespaces and resource quotas to security contexts and service accounts.
You've been busy.
My brain is buzzing with new information.
I can see why, but don't worry. We'll give you a moment to digest all this before we jump into the next part.
Okay.
We still have fascinating topics like taints and tolerations, node affinity, multi-container pod patterns, health checks,
Okay.
and even logging and monitoring to uncover.
That sounds like a lot to look forward to.
It is.
Let's take a short break and come back refreshed and ready for more Kubernetes adventures. Welcome back to our Kubernetes deep dive. We've already navigated through a lot of complex concepts, but my notes are filled with even more intriguing topics. One that really stands out is taints and tolerations. You even mentioned a mosquito and bee analogy earlier. Can you elaborate on that?
Certainly. Imagine you have a beautiful garden, but certain areas attract pesky mosquitoes. To keep them away, you might use a mosquito repellent in those specific spots. Think of that repellent as a taint in Kubernetes.
Okay.
It marks a node as unsuitable for certain pods, effectively repelling them.
So a taint is a way to say, hey, pods, stay away from this node. It's not a good fit for you.
Exactly.
But what about the bees? They're crucial for pollination, and we wouldn't want to repel them with mosquito repellent.
That's where tolerations come in.
Tolerations.
Just like you might provide a bee-friendly zone in your garden. A toleration allows a pod to override a taint and run on a node that would normally be off limits.
Okay.
It's like saying, this pod is okay with this specific condition, even though others might not be.
I see. So taints are like warnings or restrictions.
And tolerations are like exceptions to those rules.
Exactly.
But why would we even need to use taints in the first place?
Great question. Imagine you have some nodes with specialized hardware, like GPUs, that are only needed for certain types of workloads. You can use taints to prevent other pods, which don't require those resources, from being scheduled on those nodes.
So it's all about optimizing resource allocation and making sure that specialized hardware is used efficiently.
Precisely.
My notes show how to add taints to nodes using the kubectl taint command and how to add tolerations to pod definitions in YAML. It seems like a pretty powerful mechanism for controlling pod placement.
You've grasped the essence of it. Taints and tolerations give you fine-grained control over where your pods can and can't be scheduled.
Okay, so taints and tolerations are all about restrictions and exceptions. But what if we want to express preferences for where pods should run rather than hard rules? That's where node affinity comes in, right?
Precisely. Node affinity allows you to define rules that guide the scheduler in choosing the most suitable nodes for specific pods.
It's like saying, I prefer this pod to run on a node with a fast SSD. Or this pod should ideally be scheduled on a node in a specific geographic region.
It's like having a discerning diner who has specific preferences for their table, like a booth by the window or a table near the fireplace.
A delicious analogy.
Yeah.
Just like some diners are very specific about their preferences, some pods might have strict requirements. You've even highlighted the difference between required during scheduling, ignored during execution, and preferred during scheduling, ignored during execution in your notes.
Right. Those sound pretty intimidating, but I think I'm starting to get the hang of it. Required during scheduling, ignored during execution means that the specified rule must be met for a pod to be scheduled on a node.
Yes.
If no matching node is found, the pod won't be scheduled at all.
Exactly.
It's like a diner who absolutely insists on having a specific type of wine with their meal.
In preferred during scheduling, ignored during execution expresses a preference, but it's not a deal breaker.
Oh.
If a matching node isn't available, the pod might still be scheduled on a different node. It's like a diner who prefers a table by the window, but is willing to settle for a different table if none are available.
So node affinity provides a flexible way to guide the scheduler, ensuring that pods are placed on the most suitable nodes based on their needs and preferences. It's like having a thoughtful host who knows how to keep all the diners happy.
A fantastic analogy. You're really starting to see how all these pieces fit together.
Yeah. Now, up until now, we've mostly talked about pods containing a single container. But my notes mentioned multi-container pods. What are those and why would we need them?
Multi-container pods allow you to run multiple containers within a single pod, sharing resources and communicating closely.
Okay.
It's like having multiple chefs working together at the same cooking station to prepare a complex dish.
I can see the benefits of that, especially if different parts of the application need to work closely together. But I also imagine it could get pretty chaotic if those containers aren't managed carefully.
That's where common patterns for multiple container pods come in. Your notes actually list 3: sidecar, adapter, and ambassador.
Right. Those terms seemed a bit cryptic at first, but maybe you can help me decode them.
Think of a sidecar container as a helper container that provides supplemental functionality to the main application container.
All right.
It's like having a dedicated assistant who takes care of tasks like logging, monitoring, or proxying traffic.
So it's like having a sous chef who takes care of all the prep work, chopping vegetables, measuring ingredients, and keeping the station clean.
Yeah.
While the head chef focuses on the actual cooking.
A perfect analogy. Now, an adapter container is responsible for transforming data between different formats or protocols.
Yeah.
Imagine a translator who can convert recipes from one language to another, ensuring that chefs from different culinary traditions can understand and follow the instructions.
And an ambassador container acts as a proxy, routing traffic to different back-end services based on specific rules.
You got it.
It's like a host who directs diners to different dining areas based on their reservations or preferences.
These patterns offer powerful ways to structure and manage complex applications within Kubernetes, ensuring that different components can work together seamlessly.
Okay, multi-container pods are starting to make more sense now. But how do we ensure that our applications are running smoothly and that any issues are detected quickly?
That's a great question.
I see a section in my notes on probes. What are those all about?
Probes are like those little temperature checks you do to make sure the oven is at the right temperature
Okay.
or that the soup isn't too hot.
Yeah.
They allow Kubernetes to monitor the health of your containers
All right.
and take corrective action if something goes wrong.
I remember scribbling down 2 types of probes, readiness probes and liveness probes. Can you remind me what the difference is?
A readiness probe determines if a container is ready to serve traffic.
Okay.
It's like checking if the dish is fully cooked and ready to be plated.
Right.
If a container fails its readiness probe, Kubernetes won't send traffic to it.
So it's like having a quality control inspector who makes sure the food is safe and ready to be served before it goes out to the diners.
Exactly. Now, a liveness probe checks if the container is still running and healthy.
Okay.
It's like making sure the chef hasn't fainted from exhaustion in the middle of service.
Oh, no.
If a container fails its liveness probe, Kubernetes will restart it to try and restore it to a healthy state.
Okay, so readiness probes are about traffic, and liveness probes are about container health. My notes mention different ways to configure these probes, including HTTP checks, TCP checks, and even custom scripts. It seems like there's a lot of flexibility in how we can monitor our containers.
You're absolutely right. Kubernetes provides a range of options for configuring probes to suit different application needs. But probes are only one part of the monitoring picture.
Right.
You've also underlined the importance of logging and monitoring in your notes.
Right. It's like having a comprehensive kitchen dashboard that shows you everything from oven temperatures to ingredient inventory levels. But how do we actually access and interpret all this information in Kubernetes?
One of the simplest ways to view container logs is using the kubectl logs command.
Okay.
You can filter by pod name, namespace, or even specific timestamps.
So it's like having a logbook where we can see all the actions and events that have happened within our containers.
Exactly. And for more comprehensive monitoring, Kubernetes can integrate with popular third-party tools like Prometheus, Elasticstack, and Datadog.
Okay.
These tools provide dashboards, alerts, and advanced analytics to help you gain deep insights into your cluster's performance and health.
It's like having a team of data analysts constantly crunching numbers and generating reports to help us optimize the kitchen's efficiency and identify potential bottlenecks. Now I see a section in my notes on label selectors and annotations. Can you refresh my memory on what those are all about? They seem to be connected to organization and metadata.
Think of labels as tags or stickers that you can apply to Kubernetes objects, like labeling different ingredients in a kitchen. They're key value pairs that help you identify and organize resources.
And selectors are used to filter objects based on their labels, right?
Precisely.
It's like searching for all recipes that contain a specific ingredient.
You can use labels and selectors with kubectl commands to manage and query resources efficiently.
Okay.
Annotations, on the other hand, are used to attach non-identifying information to objects.
All right.
It's like adding notes to a recipe suggesting alternative ingredients or cooking techniques.
So annotations are more for human readability and don't affect how Kubernetes actually manages the resources.
Exactly. They provide a way to add supplemental information that might be useful for documentation troubleshooting or even external tools.
Okay. Labels, selectors, and annotations. Got it. Now let's talk about updates and rollbacks in deployments. I remember this being a crucial part of managing applications in a live environment.
Absolutely. Your notes highlight how deployments make it easy to update and roll back applications, like swapping out an old recipe with a new one. They explain different deployment strategies, such as recreate and rolling update.
Right. Recreate is like shutting down the entire kitchen to remodel it, while rolling update is like gradually replacing appliances and countertops one by one without disrupting service.
A perfect analogy. Recreate is simpler, but can lead to downtime, while rolling update is more complex, but minimizes or even eliminates downtime. Your notes show how to check the status and history of a rollout using kubectl rollout and how to roll back to a previous revision if needed.
It's reassuring to know that we have these tools and strategies to manage updates and rollbacks safely and efficiently.
Absolutely. Now, we've talked a lot about managing long-running applications, but what about tasks that need to run only once or on a schedule? That's where jobs and cron jobs come in.
Ah, yes. I have a whole section in my notes on those. Can you remind me what they're all about?
Jobs are used for running tasks that complete after a finite amount of time, like preparing a special dish for a single order, as opposed to continuously serving a regular menu item. Cron jobs, on the other hand, are used to schedule recurring tasks, like baking fresh bread every morning at a specific time.
So jobs are like one-time events, and cron jobs are like recurring events. My notes provide examples of both job and cron job definitions in YAML, highlighting the key fields and how to manage them using kubectl.
It seems you've been very thorough in capturing the key concepts. Now, we've covered a vast amount of ground, from the basic building blocks of pods and controllers to advanced topics like taints and tolerations, node affinity, multi-container pods, health checks, logging, and even jobs and cron jobs. But there's one crucial piece still missing. How do we actually expose our applications to the outside world?
Right. It's like having a fantastic kitchen with delicious food, but no way for diners to actually come in and enjoy it. That's where services come in, right?
Precisely. Services provide a stable endpoint for accessing applications within a cluster. It's like the restaurant's menu, listing the available dishes and how to order them. Your notes actually describe different types of services, like node port, cluster IP, and load balancer.
Ah, yes. I remember being a bit overwhelmed by all the options. Can you break them down for me?
Certainly, a node port service exposes the application on a specific port on each node in the cluster. It's a simple way to make the application accessible from outside the cluster, but it might not be the most secure or scalable option.
It's like having a single entrance to the restaurant that anyone can use. Simple, but maybe not ideal for controlling access or handling large crowds.
A great analogy. Now, a cluster IP service assigns a virtual IP address within the cluster, allowing communication between services internally. It's like having an internal phone system for the kitchen staff to communicate with each other.
So cluster IP is more for internal communication between services within the cluster and not for external access.
Exactly. And finally, a load balancer service utilizes an external load balancer to distribute traffic among multiple pods, ensuring high availability and scalability. It's like having a team of hosts who efficiently manage the flow of diners, making sure everyone gets seated and served promptly.
So load balancer is the way to go for exposing applications to the outside world in a robust and scalable way.
It's often the preferred choice for production environments where high availability and fault tolerance are critical. And to manage external access to these services, we use Ingress.
Right. Ingress acts like a traffic controller, routing incoming requests to the appropriate services based on rules we define.
Yes.
It's like having a sophisticated reservation system that directs diners to different dining areas based on their party size, reservation time, and any special requests.
You've got it. Your notes even touch on the role of ingress controllers, like Nginx or aproxy, and how to define ingress rules in YAML.
It's amazing how Kubernetes provides all these different layers of abstraction and control, from individual containers to services exposed to the outside world.
It's a testament to the power and flexibility of the platform.
Yeah.
But remember, it's not just about deploying and scaling applications. It's also about building a secure foundation for everything to run on.
Right. I have a whole section in my notes on securing the Kubernetes cluster, but I'll admit it's the area I feel the least confident about.
Security is a complex topic, but your notes demonstrate a good awareness of the key considerations. You've highlighted authentication, authorization, and TLS encryption as crucial aspects of securing the cluster.
It's like having multiple layers of security for our restaurant, from ID checks at the door to security cameras and alarms to protect against intruders.
A good analogy. Authentication verifies the identity of users or services trying to access the cluster. You've even noted different authentication methods, including static passwords, token files, certificates, and third-party identity providers.
And authorization controls what those authenticated users or services are allowed to do, like determining who can access which areas of the kitchen or who has permission to modify recipes.
Exactly. You've also noted the importance of TLS encryption, which secures the communication channels between different components of the cluster, preventing eavesdropping and tampering.
Right.
It's like having those secure phone lines for placing confidential orders.
My notes also mention role-based access control, or RBAC. What's that all about?
RBAC is a way to manage permissions based on roles.
Yes.
It's like assigning different roles to kitchen staff,
Yeah.
chefs, sous chefs, prep cooks, dishwashers,
Right.
each with specific permissions and responsibilities.
That makes perfect sense. It's a much more organized and secure way to manage permissions than just giving everyone full access to everything.
You've grasped the key principle. And finally, you have a note about admission controllers. Think of these as bouncers at the door, enforcing policies on incoming requests.
So they're like the gatekeepers who make sure only authorized individuals are allowed in and that they meet the dress code and other requirements.
Precisely. Admission controllers can enforce a wide range of policies, ensuring that only valid and safe requests are processed by the cluster.
Wow, we've really come a long way in this deep dive. My initial goal was to get a grip on Kubernetes, and I feel like we've done that and so much more.
Your notes are incredibly insightful, and it's been a pleasure exploring them with you.
Well, thank you.
It's clear you have a natural curiosity and a knack for connecting complex technical concepts to real-world analogies.
I have to admit, I was a bit intimidated by Kubernetes at first. But by breaking it down step by step and with your guidance, it's become much more approachable.
That's the beauty of learning, taking something complex and making it understandable. And remember, this is just the beginning of your Kubernetes journey. There's a whole world of resources, communities, and tools out there to help you deepen your knowledge and explore the endless possibilities of this powerful platform.
I'm excited to continue learning and experimenting with everything we've covered today. I can already see how Kubernetes can be used to build and manage incredibly complex and scalable applications.
And who knows, maybe you'll be sharing your own Kubernetes expertise with the world someday. Keep exploring, keep learning, and keep pushing the boundaries of what's possible with this amazing technology.
Thank you so much for joining me on this deep dive. I feel like I've gained a solid understanding of Kubernetes, and I'm eager to put my newfound knowledge into practice.
It's been a pleasure. Happy Kubernetes.